Some objects sink almost instantly, while others move slowly through a liquid. But what happens when the liquid itself isn't uniform? My name is Pokushoy Sorin, and for this STEM project, I investigated how mixing oil with different liquids changes the way objects sink. This project is called Liquid Density and Sinking Speed. Sinking behavior is controlled by two main fluid properties: density and viscosity. Density describes how heavy a liquid is for its size, while viscosity describes how resistant it is to flow. Oil is interesting because it is less dense but more viscous than water-based liquids, and it naturally forms layers when mixed with them. These layered fluids create different resistance forces, which can significantly change how objects move through them. My research question was, how does mixing oil with water, soda, or vinegar affect the sinking speed of solid objects? I hypothesized that objects will sink at different speeds in each mixture due to changes in density, viscosity, and fluid layering. To test this, I designed a controlled experiment. I used identical containers and released each object from the same height above the liquid surface. The objects tested were a coin, a paperclip, and a hair clip. The liquid conditions included oil mixed with water, soda, and vinegar, as well as pure oil as a control. Each object was dropped multiple times in each liquid condition. Sinking time was measured by analyzing recorded video footage, starting when the object entered the liquid and ending when it reached the bottom. The results showed clear and consistent patterns. Objects sank the fastest in the pure oil and the slowest in the oil and soda mixture. The oil, water, and oil vinegar mixtures produced intermediate sinking speeds. Although oil is viscous, its uniform structure allowed objects to move smoothly. In contrast, mixed liquids create layered resistance, causing additional drag and slowing the objects down. The soda mixture showed the greatest resistance, likely due to carbonation and dissolved substances increasing drag. These findings demonstrate that sinking speed is not controlled by a single property. Instead, it depends on the interaction between density, viscosity, and how different fluids interact when layered. This explains why fluid behavior in real-world environments is often complex and difficult to predict. One unexpected result was that objects sank faster in pure oil than any mixture, even though oil is thicker. This showed that uniform viscosity can allow smoother motion than layered liquids, where resistance changes as an object moves downward. Understanding how objects move through mixed fluids is important in fields such as environmental science, marine engineering, chemical processing, and oil spill analysis. This experiment highlights how small changes in fluid composition can produce large changes in motion. In conclusion, mixing oil with different liquids significantly changes sinking behavior. This project demonstrates that fluid dynamics depends on multiple interacting properties, not just density alone. Thank you for watching.